Okay. So I said chapter 7 will be about the distinction between chapter 7a will be about the distinction between random variables, between continuous and discrete, right? Continuous and discrete. Now we're looking specifically at discrete variables, and we're looking at a probability distribution. All right, and so what that means, if we've got a random variable x, we use capital X to describe the random variable, and we use lowercase x to describe the events that can occur because of it. So there is some information to read through. I'm going to leave that for you to have a look at, and let's get straight into the examples, right? So x is the events that can occur. So a good example here might be a spinner. Okay, if you've got a spinner, like you think of a pie, and there's 4 possible events. You can get a 1, a 2, a 3, or a 4. Although in this circumstance, they're not equally weighted, are they? If they were equally weighted, it would be 0.25 each way, and that's a special case, what we call a uniform probability distribution. But we've got 1 is 0.2, so that's going to be a fifth, and then we've got 2, we're not sure yet. 3 is going to be 0.24, so it's 24% of the pie. 4 is going to be 22% of the pie. All right, it can be a spinner, okay? And you can see it has to take on a discrete value because either one of these, and we've got the probabilities of these events occurring. Can anyone tell me what's k going to be? How could we figure that out? Vinny?
Well, so if the entire probability is 1,
Very
it's
good.
just all of the other ones, 1 take away all of the other probabilities, that's what k is.
Excellent, very good. So this is what we say. The sum of all probable events is 1, okay? The spinner has to take on one of these events, okay? The probability that the random variable takes on this event is equal to these, so they all have to add to 1. The sum of all probable events is 1, okay? The other caveat, of course, is none of the probabilities can be negative. You can't have a negative probability. A probability has to occur between 0 and 1. So let's figure out k. 1 take away 0.2, take 0.24, take 0.22. So what's that going to equal? We've got 0.8, that's together is 0.46, and that's going to be 0.34. Is that right? Yeah. Cool. All right, so we've got k is 0.34. Move on. Is this a uniform discrete distribution? So a uniform discrete distribution is a special case where all probabilities are equal. Are all probabilities equal? No. No, because not all probabilities are equal. Or all events are not equally likely. All right, so an example of a uniform discrete probability is rolling a dice, right? If it's a fair dice, each event has a probability of 1 in 6. If it's a fair spinner, each event has a probability of 0.25. Okay, part C. Find the probability of x being larger than or equal to 2. All right, so what does this mean? Capital X is the random variable. What's the probability that when you spin this spinner, it takes on a value that is larger than or equal to 2? It means these events, right? The event 2, or event 3, or event 4. All of those will satisfy this statement, this contingency. So we've got k, I'll replace that now because we've calculated it. It'll be 0.34 plus 0.24 plus 0.22. Okay. Find the mode of the distribution. All right, so the mode is the event that has the highest probability. So if we're looking along, where's the highest probability? Here. So the mode is 2. The mode is when the random variable is equal to 2. All right. And the median, okay, so this is the last point written at the bottom. The median is the event that corresponds when the cumulative sum of probability reaches or exceeds 0.5. Okay? So the median is not 1 because the probability is 0.2. But then if I move on to the next event, event 2 here, right, we have 0.2 plus 0.34. The probability there combined is 0.54, which has exceeded 0.5. So the median corresponds with here because it's when the cumulative probability reaches or exceeds 0.5. 2. Alright, and so the median and the mode are never about what's the probability, they're always about the events. What's the event that occurs? Okay. So that's question 1 all answered, isn't it? Any questions about that? Alright, so I will, after we finish here, do have a read of what's written there, but we have sort of touched on it all so far. Let's move on to the next example. Over the page. Yeah. Okay, so we can have a probability distribution table, or we can have a probability distribution function. So here we've got kx on 4, and we're told this is a valid probability distribution function for the events 0, no, for events x is 1, 2, or 3. And so we're told the random variable can take these values. The probability that it will take these values is given by this function. Okay? So the only way we're taking this a bit further is we're giving you a function and now we're saying generate this table. We're giving you a function, now generate this table. We're told the events it can take. The possible events are x is 1, x is 2, and x is 3. Here is the probability distribution function. Alright, so the random variable can take these events. What's the probability of it taking each specific event? Well, if you put x is 1 into this equation, you would have k on 4. If you put x is 2 into this equation, you would have 2k on 4. Can be simplified, but we won't, and I'll show you why we won't. And if you put x is 3 into this equation, you have 3k on 4. Alright, so we've got probabilities there in terms of k. And we know that the sum of all probable events is 1. So that means k on 4 plus 2k on 4 plus 3k on 4 equals 1. Alright, we'll collect those. This is why we didn't simplify that before. They have the same denominator, so it's 6k on 4 equals 1. Alright, I'm going to multiply both sides by 4 on top of 6. Alright, 4 at the top, 4 at the bottom, 6 at the top, 6 at the bottom. We've got k is 4 over 6. And now we can simplify it, right? K is 2 on top of 3. Alright, so we went through, and that's really our answer to part A, isn't it? We've found the value of k. Alright, part B says to draw the probability distribution. So here I've got a probability distribution table. In the next part, we might represent it as a graph. Now here, I don't have probabilities labeled. I've got them in terms of k, and I know if k is 2 on 3, then I can go through and calculate these, right? 2 on 3 on top of 4, 2/3 on top of 4. Well, one way we can write 4 is 4 on top of 1, AD on top of BC, 1 on 6, okay? So this probability here simplifies to 1 on 6. Alright, if you're going to do it with the next one, here it's 2 times 2/3, so it's 4 on 3. 4 on 3 on top of 4. So again, AD on BC. So we've got 4 on 12, 2 on 6. Alright, and then lastly, this one has to be 3 on 6. You can see that they all add up to 1. And I do think it is useful to keep them with the same denominator. All right, yes, you can simplify, but expressed in this table here, it's useful for us to see that they all add up to 1. Okay, so if you're going to draw that probability distribution, all right, if you're going to draw it as a histogram, what we'll have on the y-axis are the probabilities, and what we'll have on the x-axis are the events. So the events are 1, 2, and 3. And I'll just divide this up into 6s. Here we've got 1 on 6, 2 on 6, 3 on 6. You can keep going, 4 on 6. And the probability of event 1 is 1 on 6. The probability of event 2, 2 on 6. The probability of event 3, 3 on 6. Okay? So which event is most likely? Maybe that's what we'll ask in a moment. We'll ask that in a moment. Alright, but it's just showing we can represent it as a graph, alright, or we can represent it in a table. And 95% of the time we do it like this. It's just showing a relationship between the two. Okay, find the median and the mode. Alright, let's do the mode first because that's going to be the easiest one. The mode is the event that corresponds with the highest probability. So the event that corresponds with the highest probability is 3. It's when the random variable, capital X, equals 3. The median is the event that corresponds when the cumulative probability reaches 0.5. So if we look at the probability, here we've got 1 on 6, that's not 0.5 yet. 1 on 6 plus 2 on 6 is 3 on 6, which is 0.5. The median corresponds with X is 2. All right. Splendid. So let's have a go at 7B.